Hello friends, welcome back. My name is Sarveshwar. Today we will discuss a very important thing in market microstructure literature, that is estimating Thompson and Waller 1987 bid ask spread estimate. Sometimes we are not having all the data we need for our research. In that situation, we can estimate that data in of the actual one. So Thompson and Waller comes here for the rescue. So how to do that? Uh, because bid ask simply is an estimation of transaction cost. Okay, to do that, first of all, I need a file. This is a file of Nifty, the Indian Stock Exchange index data for 3 year period from 1st January 2012 to December 14. Uh, 5 minute data 920 925 for spot and future series. We will be discussing only spot because our task is to understand how to compute bid ask spread. In the similar way, we can do for futures as well. So, this is a file. Now, here we can see the file is having date and time, but we need date only. So, I'm adding one more column for that. This is the way I had done. Simple formula, you can look after whatever you want. I'm just making a unique column vector that gives me what is the number of unique dates. So if I see, it is giving me 735 trading days. For each trading day, based on this 5 minute transaction data, I want to estimate bid ask spread. How to do that? Okay, for that purpose, I need to make sure that you know two things. First, what is Thomson Waller bid ask spread? Second thing, you know for loop, just to compute it for each trading day in a very efficient manner. So first of all, what is this Thomson Waller TW spread? So this is the formula they have mentioned in their paper. P is price, del P price changes. So del PT means PT minus 1, but not log. It is simply price changes. Then these absolute values and then taking the mean of that. Here the T is not simple all the values. The values those are having non-zero price changes would be considered here only. But if any value that is having no price change means zero return, that will not be considered for computation of this TW spread, Thomson Waller spread. Okay, so here we can say simply the mean of um, non-zero price changes, absolute non-zero price changes, the mean of absolute non-zero price changes would be Thomson Waller spread. So here we are having 5 minute transaction data for each the firm. So I can say simply like for example I say uh, suppose out of this entire file I need data for a certain date. Suppose I say for 2nd January only. So what I'm doing here, just for the sake of explanation, what I'm doing here, this is the way. Okay, I'm just subsetting the data by giving command key only date, say first column should be coming here. Then if I see this is my column, it is having only 75 entries for spot and futures for a certain date, only 2nd January. Similarly for other dates I can do that. uh, Now I'm having extra columns time and date. I need to remove that by this command. I am just removing them and then taking difference of spot. So now if I see y11 is giving me 74 price changes. Here I am computing by giving length and which command key. Out of these 74 observations, how many of them are not equal to 0? 74 are there. So I'm just giving a variable name, non-zero price changes spot. Similarly, I'm just adding it to the existing one, the null vector I'm created just to uh, using in loop. Now, the main thing we would be discussing here is this one, how to compute this spread. So if we go there in the formula, it says price changes absolute values. So price changes we have already done in y11. So y11 then absolute of this. Okay, price changes absolute and summation of it, and then divided by 1 by t, non-zero price changes divided by non-zero price changes. So we have done the formula. If we do this, we can get it. Now add it to the null vector just to make an entire vector of for each date. So this is where we can do that. Now I would be running this for the entire files. Okay, friends, just to clean the slat, and then I'm doing that for you. First, this is a file. Make a unique date vector, two null vector just to make a complete vector at the end of loop. This is the loop would be computing. It will take a ziffy or 30-second maximum for entire 735 trading days. It's over now. Now we can see I'm just putting them all together and then giving the names to the column. The results are here now. If I see these are the results for each date, how many number of non-zero price changes and Thompson Waller spread is given by here. It is in rupees. So this is the way, friends, we can compute Thompson Waller spread. This is a major the situation when you are having high frequency data for every day, but you are not having luxury to having bid ask spread. In that situation, we can compute it, we can estimate it. These are only estimates, which could be helpful in your transaction cost analysis for price discovery analysis or any other thing in market microstructure. Thanks a lot, friend, for watching. Keep watching.